Hi guys, you're welcome to my channel. Today we are going to continue with our Jamb series, but today we are having mathematics. I want you guys to take this series so serious. I'm very sure if you can follow it in detail, you are going to blast your Jamb. So we are also starting with 2010 with mathematics, just like we did with physics. So question number 2, remember question number 1 is question you cannot fail. Gone are those days that they will ask you what paper type do you have with you, and of course if you are not blind, even when you are blind they will tell you. So it's a bonus question. I remember when my mentor used to say this day that if you fail number 1 question in Jamb, then you are crazy. I always wondered why, until I also sat for the exam that year. So let's get started, guys. Now the question here, as you can see on the screen right now, states that find R if 6R7 in base 8 equal 511 in base 9. Option A 5, option B 2, option C S. I don't know if that is the typing error. Then option D 6. So without wasting our time, let's get started. The first thing we always do as usual is to identify the topic, and after identifying the topic we break it down and understand everything about that topic such that we can answer any Jamb questions on it. So what's this topic? The topic is number system. What exactly do you need to know on number system as a Jambite? Number 1, you need to understand why or what we call number system. Number 2, you need to understand the arithmetic of number system. Number 3, you need to understand how to convert from one number base to another. So without wasting much of our time, let's get started. Now, when you talk about number system, we are simply talking about the counting of numbers. When you talk about counting of numbers, you know, if you count from 1, you count to 10, and you start from 11 again, you count to 20, you start from 21, you count to 30. When you look at all this counting, when you count the numbers of digits you have here, you get to see that it makes 10. When you count the numbers of digits you have here, it's also 10. Count the numbers of digits you have here, it's also 10. So what does that mean? When you are counting in a particular base, the numbers of digits that equals to that base makes a bundle. When you are counting in a certain number base, the numbers of digits that makes up that base makes it what? A bundle. What do I mean? Let's look up now. So if I'm counting in base 10, if I count 10 digits, that makes a bundle. If I count another 10 digits, that makes it 2 bundle. That means from 1 to 20, we have 2 bundle. 20 divided by 10, that is 2. Is that taken now? So now let us understand each of the base and what are the rules, what are the things we should check on every basis, so that we are going to know if it is right or wrong. So let's check. If I have base 10, I don't need to write base as BS. So base 10, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to be the digits that I can have there. If I have base 9, the digits I can have is 0, 1, 2, 3, 4, 5, 6, 7, 8. If I have base 8, the digits I can have is 0, 1, 2, 3, 4, 5, 6, and then 7. If I have base 7, I have 0, 1, 2, 3, 4, 5, 6. If I have base 6, I have 0, 1, 2, 3, 4, and 5. If I have base 5, yeah, that's 0, 1, 2, 3, 4. If I have base 4, I'll have 0, 1, 2, 3. If I have base 3, I'll have 0, 1, 2. If I have base 2, I'll have 0, 1. What's the significance and the meaning of all these digits? The reason is to tell you when you are having a particular base, what are the number expected in that particular base. So if you look at all these digits, when the number is in base 10, highest digit there is base 9, is 9 rather. When the number is in base 9, highest digit there is what? 8. When the number is in base 8, highest digit there is what? 7. You can see that the highest digit in every number base is always 1 less than the base. So you cannot have a number that is greater than the base or a number that is equal to its base. For that reason, You need to understand this very well. So let me ask you this particular question, and I would like you to respond. If I have 2, 3, 4 in base 4, and I have 2, 3, 4, okay, I have 2, 3, 4 in base 3, and I have 2, 3, 4 in base 5. Which of the three is correct, and why are they correct? Alright, thank you for answering that question. You just see that this one is wrong. Why is it wrong? Because we have a number that is part of these 3 digits that is equivalent to the base, and you must not have a number that's equivalent to its base. So that means this is wrong. If you check the second one, it is wrong because we have what? A number that is greater than the base there. So 4 is greater than the base. That's why this is wrong. Also 3 is equal to the base. So this is very, very wrong. So if you check the last one, I guess it should be correct. Do we have a number equal to the base? No. Do we have a number greater than the base? No. So all numbers here are slow. All numbers here, they are lesser than the base, and that makes this to be correct. Do you understand that now? So you should always check out for that in your workings, or when your mate wants to disturb you and they give you a question, because WAEC or Jamb will not make such mistake. Is that taken now? But you can find it in your option if they want to test you, if you really understand this. But I believe none of my students or you that you are watching this will make such mistake. So let's dive into the next part of the video, which is the arithmetic of number base system. So we are starting with addition of number base. Now, how do we have number together in bases aside from base 10? We are all familiar with how to have number together in base 10, but a lot of us are not familiar with how to have number of in other bases, or we are still making some mistake or the other. So here is the class for you. Alright, so let's say I have 2, 3, 4 in base 5, and I have 1, 3, 2 in base 5. I want to add these 2 digits together. How do I do that? Remember, the number you have to write down when you are adding is the remainder. Why the remainder? Let's say I had 4 plus 2 together. My result is what? 6. If I write down 6 here, it should be greater than the base, and we don't want a number that will equal or greater than the base. For that reason, I will say that 6 divided by 5, that will give me 1 remainder 1. So I'll write down the remainder, which is 1, and I will take the remaining 1 to this side. 3 plus 3, that is 6, plus 1, that is 7. 7 is greater than 5. I will have this to be 7 divided by 5, and that will be 1 remainder 2. So I'll write down the remainder, which is 2, and take 1 to this side. 2 plus 1, that's 3, plus that 1, that will make it 4. So I have 4, 2, 1 in base what? Base 5. So we put this one in base 5. Do you understand this now? So if you get this, that is how to have number together in number bases. You add, once the result of the addition is greater than the base, you divide the base with that result, and you write down the remainder, and you take away the numbers of time that number can go. Is that taken now? Let's take one more example so that you understand what I'm saying clearly. Let's take for instance that I have a digit like 4, 3, 2 in base 5. Let me say base 6 this time around, and I add let's say I add 5, 1, 4 in base 6 also. So let's add these 2 digits together. So 2 plus 4, that will give us 6. 6 is what? Is also the base. So that means you have to say 6 divided by 6, that will be 1 remainder 0. So you write down 0 and you take 1. 3 plus 1, that is 4, plus 1, that is 5. 4 plus 5, that will give us 9. So you have to say 9 divided by 5, that will give us 1 remainder 4. So you write down the remainder, which is 4, and then the 1, you take it to the front. So your result is going to be 1450 in base 6. That is how to have number together in number bases. So the next one we have to move on to now is the subtraction. And how do we carry out subtraction of number bases? We carry out the subtraction of number bases by considering the number that we are borrowing from. No, the issue with subtraction is to borrow from one place to another. And you know, when you are dealing with base 10, when you borrow from one number to another number, that number you borrow is equivalent to 10. But here, the number you are borrowing must be the same value as your base. You don't understand what I mean? Let's see. Let's take for instance that I have a digit like 213 in base 4 and I have 105. Okay, sorry, this will be a wrong number. Let me put it like this. Let's say I have 253 in base 6 and I have 315 in base 6. Okay, so this is cool. We have to take the subtraction of these two digits here. So what are we going to do in essence? Okay, let me recast this question better. Okay, let's say I have 345 in, so let me say 340 in base 5 and I have 213 in base 5. Alright, so let's take the subtraction. This is 0 minus 3, right? So 0 minus 3 is impossible. I will have to borrow 1 from here to this place. Borrowing 1 from here to this place, that 1 must equivalent to the base. You know, the base is 5. So if I borrow 1 from here to this place now, this will become 5. So I will say 5 minus 3, that will give me 2. And then here we are going to have 3 left. 3 minus 1, that will give me 2. This one is going to be 3 minus 2, that is going to give me 1. So our result is going to be 1225, 122 in base 5. Do you understand that now? So that is how to go by subtraction. So let's take one more example. Let's say I have 354 in, let's say, okay, should I still go with base 5? Yes, let's still go with base 5. And I have, let's say, 132, for example, in base 5. So here you might not need to borrow because the number here is extremely small compared to the one above. But let me cast it so that we are going to borrow. So let's say 304 in base 5, and here I have 132 in base 5. Yeah. So 4 minus 2, that will give us 2. We don't need to borrow. So 0 minus 3 is impossible. So borrow 1 from here to this place. That one is equivalent to 5. So we have 5 minus 3, that will give us 2. And this one is going to remain 2. 2 minus 1, that is 1. So in base 5. Wow. So I never planned it before, but it turned out that this minus this is the same result as this minus this. So it's awesome. Mathematics is cool. So that's just what you just need to understand when you are dealing with subtraction of number base. So the next one you have to look at now is the multiplication of number base. So how do you multiply number base together? It's just the same thing like what you did in addition. So let's say I have 314 in base 5 to be multiplied by, let's say, 3 in base 5, for example. So we say 3 times 4, that is going to give us 12. 12 is greater than 5. We say 12 divided by 5, that will give us 2 remainder 2. So if you write down 2 and you take the remaining 2 here, 3 times 1 is what? 3 plus 2, that's 5. 5 is in the base. So you say 5 divided by 5, 1 remainder 0. So you write down 0 and you take down the remainder. 3 times 3, that's 9, plus 1, that's 10. So you say 10 divided by 5, that will give us what? That will give us 2 remainder 0. So you have to write down the 0 and take the 2 here. So this will give us our result. So 314 in base 5 multiplied by 3 in base 5 will give us 2002 in base 5. Is that clear now? So that's how to go about multiplication. Okay, let's make it more advanced a bit. Let's say I have 314 in base 6, for example, to be multiplied by 215 in base 6. For example, like this, we want to multiply these two together. So 5 times 4 will give us 20, right? So 20 is greater than 6, so we say 20 divided by 6, that will give us 3 remainder 2, and we write down 2 and we take 3 to this side. 5 times 1 is 5 plus 2, that's 7. 7 is greater than 6, so we say 7 divided by 6, that will be 1 remainder 1. So we write down 1 and we take the remaining 1 to this side. So 5 times 5, that 5 times 3 rather, that would be what? 15 plus 1, that's 16. So we have 16 divided by 5. That will give us what? That will give us 16 divided by 5, that's 3 remainder 1. Do you get that now? So we write down what? 1 and take the 3 to this side. Do you understand that now? Alright, so if that should be the case, let's move to the next digit. 1 times 4, that will give us 4 is not greater or equal to 6. So we just write down the 4. 1 times 1, that is 1. 1 times 3, that is 3. So we move to the next one, which is 2. We say what? 2 times 4, that's 8. 8 is greater than 6. So you say what? 8 divided by 6, that will be 1 remainder 2. So you write down 2 and you take 1. So 2 times 1, that's 2, plus 1, that's 3. So you have 3 here. And then 2 times 3, that's 6, is equivalent to 6. So you say 6 divided by 6, that will be 1 remainder 0. So you write down what? 0 and then 1. So without wasting much of our time, we have this together. So we have 2. We are going to have 5 here. 1 plus 1 plus 2, that will give us 4. 3 plus 3 plus 3, that will give us 9. So we say 9 divided by 6, that will give us 1 remainder 3. So we write down there the remainder, which is 3, and we take 1 to this side. So 1 plus 0, that's 1. Then we drop this one in base 6. So that will be our results. I hope you enjoy this now and you understand. I want to believe that you already understand how to do multiplication of number base right now. So if you understand how to do multiplication of number base right now, then you can let us move down to division. Okay? So how do we go about dividing number bases? Now this is in case whereby students ask me often and often, they always find it difficult to divide number bases. It's quite simple, and this is what I will advise you to do. Whenever, let's take for instance, I have 1, 3, 4. Okay, the question, let's say the question says divide 1, 3, 4 by 4 in base 5. So that is 1, 3, 4 in base 5 divided by 4 in base 5. That's the question. So how do we do that? For you to be able to do that, all you just need to do first is to generate the product of 4 in base 5. When I say product of 4 in base 5, what are the digits in base 5? You know, 0, 1, 2, 3, 4. Those are the digits in base 5, right? So we are going to use 4 to multiply each digit in base 5, and then we have generated the product of 4 in base 5. So let's get started, guys. So we have 4 in base 5 multiplied by the first digit there is what? 0. So that's 0 in base 5. That will give us 0. Then we pick the next digit, which is 1. So we say 4 in base 5 multiplied by 1 in base 5. 4 times 1, that is 4 in base 5. Then the next one is 2. So 4 in base 5 times 2 in base 5. 4 times 2 is 8. 8 is greater than 5, right? So you see 8 divided by 5, that will give you 1 remainder 3. So you have to write down the 3 and the 1, you take it to the front. So this should be 13 in base 5. So the next thing to do is to say 4 in base 5 times the next digit, which is 3 in base 5. So 4 times 3 is going to give us 12. 5 in 12 will give us 2 remainder 2. So you write down 2 and take the remaining 2 in base 5. So that will be 2 in base 5. Then we have 4 in base 5 multiplied by 4 in base 5. 4 times 4 is 16. 16 divided by 5 is going to be 3 remainder 1. So you write down what? 1 and take the 3 here. Is that taken now? So we are done with the multiplication table of 4 in base 5. We cannot have 5 because 5 is not part of the digits in base 5. Is that taken now? Now, how do we use this multiplication table in carrying out our division? So it's something so simple. So let me just draw my long division here. And I have 4 in base 5 here. And the digits to divide is 1, 3, 4 in base 5. So if I say 1 divided by 4, that will give me what? 0. Why 0? Is because there's no digits that I can multiply together, that can multiply with 4 in base 5 that will give me 1, or a number closer to what? To 1 other than 0. So that's why this should be 0. There is no point in writing the 0 because it is a leading 0, and leading 0 is insignificant. So if that should be the case, let's put these two together. This become what? 13. So 13 divided by 4, that will give us what? So when it comes to check here, is there any digits that multiply 4 in base 5 that the result is 13 in base 5? And we have 1, and that is what? 2. So 2 multiplied by 4 in base 5 is going to give us what? 13. So if I say 13 divided by 4 in base 5, my result is going to be that 2. Do you understand that now? So we say 2 times 5, 2 times 4 in base 5, that will give us what? 13. So this will become what? Just 4 in base 5. You don't need to indicate the base, then let's just remove that. So we have 4 left here now. So if I say 4 divided by 4 in base 5, what would that give us? So is there any number that I can use to multiply 4 that will give me what? That I can use to multiply 4 in base 5 that will give me this 4? Yes, there is, and that is 1. So I'll put down 1 here. Are you following now? So 1 times this, that will be what? 4, and our result is going to be 0. So since our result becomes 0 right now, so we can now say 134 in base 5 divided by 4 in base 5 is equal to 21 in base 5. Do you understand how we go about that now? So it's pretty much simple like that. So let's see what else can we do. Let's try another figure. So we want to try another digit and see what our results can be. So divide, I shouldn't have cleaned that because I would have liked to use that as the other example, but anyway, so let's start. Let's say divide 325. Okay, no, this can be, let's say 324 in base 5 by 4 in base 5. So we have this now. So this is 324 in base 5, and this is 4 in base 5. So let's check. We're supposed to quickly create the multiplication table for 4 in base 5. So this is going to give us 0, and this is going to give us 4, and this is going to give us 13. Sorry, this is supposed to be 2. So this will give us 13, and 4 in base 5 times 3 in base 5. This will give us 12, that will be 22, and then 4 in base 5 times, what is it called? 4 in base 5, that's 16, that's 15, 3, remember 1, so that will be what? 31 in base 5. So we quickly generate that. I've done that earlier, so you understand the way I did it, right? Fine. So 4 in 3, that's 3 divided by 4. Is there any number that we can use to divide that? That will go. So we don't have, because the digit here is 4 and it's greater than that 3. So we put these two together, that's 32. 32 divided by 4. Is there any number here that gives us 32? No. But we have a number that gives us what? 31. So 31 is very close to what? 32. So we say 4. 4 times 4. The reason why we say 4 is because it is 4 that multiply 4 that will give us what? A result closer to 32. Do you understand that? So 4 times 4, that will give us 31. So we have what? This will give us 1, right? And this is what? This will just come down. That's 4. So 14 divided by 4. Do you have a number that gives us 14 there? No, but we have a number closer to 14. That's 13. And what is that number that multiplies 4 to give that 13? That's what? 2. So we write down 2 here. So we say 2 multiplied by 4, that will give us 8, right? So 2 multiplied by 4, that will give us 13. So we have this. So when we take the difference here, we just add the 1. Is there any number that 4 can divide and give us 1? There is no number. So this is going to become a remainder. So we are going to write your result as 42 in base 5, remainder 1 in base 5. Do you get this clearly now? So it's so simple like that. So that's how to carry out division under number base. Is that okay now? So you can try this and let me know what your answer will be in the comment section. 101 divided by 144 in base 8. So let's see what your result will be in the comment section. So if I get to see that, I can easily direct you to my DM, and whichever mistake you are making, I can let you know. Is that okay now? But let me know what the answer is in the comment section. Alright, so what's the next thing to look at under number base after we have considered we've considered the arithmetic of number base? The next thing to consider under number base is just pretty much how to convert from one base to another. So let's get started and look into that. So the first thing is how to convert to base 10. So I want to learn how to convert to base 10. Let's say I have a digit like this, 132 in base, let's say base 5, okay? Let's say base 5 for example. And I want to convert this to base 10. How do I go about it? For me to be able to do this, it's pretty much simple. What I'm going to do first is that, I'm converting to base 10. So let me put it at the top. Conversion to base 10. Now, base 10 has another name other than calling it base 10. You can call it binary number. So if they say binary and base 2, you can call it binary. So you should understand that without taking. So for you to convert 132 in base 5 to base 10, you pick first each digit here, you multiply them by 5 plus the next one, multiply it by 5 plus the next one, multiply it by 5. Are you there now? So the next thing we want to do now is to do their place value. That is, let me rewrite it here so that you can understand the step one after the other, should in case you are doing this for the first time. So you put this one to the power of 0, this one to the power of 1, this one to the power of 2. So this one is going to become 1 multiplied by 25 plus, because 5 raised to power 2 is 25. Now 5 raised to power 2 does not mean 5 times 2. 5 raised to power 2 means 5 times 5. It means 5 multiply itself twice. Is that okay now? So that's why this gives us 25. Now this one is still what? 5, so we leave it as 3 times 5. So plus anything that raised to power of 0, provided that that thing is not 0, the result is what? 1. So 1 times 25 will give us 25 plus 3 times 5, that's 15, plus 2 times 1, that's 2. So what will be our results, guys? Okay, 25 times 5, that will give us 40, right? And plus 2, that's 42 in base 10. Are you there now? So 132 in base 5 is equal to 42 in base 10. Or I can write it without indicating the base. When they write a number like this without indicating the base, just know that it is in base 10. Is that okay now? So, but let me just indicate the base. So that's how to convert from one base to base 10. Any digits you have there, just multiply each digit by the base, and then you fill the second step by placing their value. Then the third step, then you can arrive at your answer. I believe the summary is clear, right? Now let's see how to convert from base 10 to another base. Let's see how to convert from base 10 to another base. And I'd like us to use this same example. So let's say we have 42 in base 10 and want to convert it to base 5. So let's see what it's going to look like. So I'll say convert. So convert from base 10 to another base. Yeah. So let's see that if I say convert 42 in base 10 to base 5. So let's see what the result will be. So how do you do that? You do that by division. So you have this. This is what you do when you are converting from base 10 to another base. The number you are converting, you put it here. The base you want to convert to, you put it here, and this is your remainder. Are you seeing the table? So we'll say 5 in 42. 5 in 42 will give us 8, because 8 times 5 will give us 40. So we have what? 8 remainder 2. Are you seeing this now? So 5 in 8, that will give us 1 remainder 3. So 5 in 1 is going to be 0, because 5 cannot go in 1, so remainder 1. So that's all. You stop here and you pick your digit from down upward. So that will be 1, 3, 2 in what? Base 5. Now, if you look at it since morning, I've not been writing this. I've always been putting it as 5. I'm putting it like that because you are a Jamb student, not YX student. YX student, I relay emphasis that you should always write it in words instead of figure. Is that taken now? So we can now conclude that 42 in base 10 is equal to 132 in base 5. Do you understand this now? So that's how to go about converting from base 10 to another base. All you just need to do is to divide that number in base 10 by the base you are converting to, and write down the remainder. And once you get to 0 here, take the remainder from down upward. You can see we go from down upward. That's why we have 132 in base 5. Is that clear now? Alright, so if that should be the case, let's move on to the next part. And what is the next part, guys? The next part of conversion is how to convert from one base to another base other than base 10. So let's say conversion from one base to another base. Conversion from one base to another. So we are converting from one base to another base other than base 10. So let's say I have 132 in base 5, and I ask you to convert it to base 2. For example, now, do you see that now? You're converting 132 in base 5 to base 2. You can see that base 2 is different from base 10. So what are you going to do? What you're going to do is that you have to convert this number 132 in base 5. You first of all convert it to base 10. Then after converting it to base 10, you can now convert the result you have in base 10. You convert it to the required base. So let's see how we do that. We say 132 in base 5 is going to become 1 multiplied by 5 plus 3 multiplied by 5 plus 2 multiplied by 5. Then we have 1 multiplied by 5 plus 3 multiplied by 5 plus 2 multiplied by 5. Are you following, guys? So you put the power 0, 1, 2. So you have here 1 multiplied by 25 plus 3 multiplied by 5 plus 2 multiplied by 1. Is that taken now? So this will give us what? 25. And this will give us 15. And this will give us 2. So that makes what? 42 in base 10. Do you guys understand this now? So this 42 we now have in base 10, we are now going to convert it to base 2. So we just draw. So the number we are converting is 2, the base we are converting to is 2, and then we have the radius. The number we are converting is 42 rather. So 2 in 42, that will give us 21, if I'm not mistaken, remainder 0. So 2 in 21, that will be 10, remainder 1. 2 in 10, that will be 5, remainder 0. 2 in 5, that will be 2, remainder 1. 2 in 2, that will be 1, remainder 0. 2 in 1, that is 0, remainder 1. So you take it from down upward, and you're going to have 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0 in base 2. Do you understand that now? So how do you report your result? You just say 132 in base 5 equal to 42 in base 10 equal 101010 in base 2. So for that reason, 132 in base 5 is equal to 101010 in base 2. So that's just how to convert from one base to another base other than base 10. I believe this is clear now. So you can now solve the question given to you, but before you go, let's treat like 2 questions that look similar to that, and when you are done, you can just let me know what your answer is in the comment section when you're done solving the original question that you are seeing on your screen right now, so in case you forget it. So can you see the question now? Fine, so solve it and let me know your answer in the comment section. Write the answer, don't write the option, or you can write the option and the answer, anyone. So let's get started with like 2 to 3 examples. Okay, so let's see the first example, also from Jamb Park. So I'm trying to check my past question here and see which should we look at. So this is 1984 number 2. 1984 number 2. The question says, if 263 plus 441 equal 714, what number base has been used? What number base has been used? So we have option A 12, option B 11, option C 10, option D 9, option E 8. Alright, so there is a question given to us. So let's see how we can do that. And I believe this should be very simple for us to do. Now, if I were you, I will first of all rule out this. And I'm still going to be talking about tricks to answer objective questions subsequently in this class. So I will cancel these two first. Is that taken? Because the curriculum of Jamb does not cover a base more than base 10. So having these two there is off. So I'll focus on these three. So let's go on now. So our answer should be within these three. So let's see. I'll say let the base be, what is your name? Name. Cool. So let it be n. So if it is n, I will have that 263 in this n plus 441 in this n equals 714 in this n. So what will I do? What I can do is that it is very easy for me to convert everything to base 10. And when I convert it to base 10, I can do normal arithmetic without going or anything, you get. So let's convert everything here to base 10. So we have 2 multiplied by n plus 6 multiplied by n plus 3 multiplied by n. Then the big plus. Note that. But before you write that, to avoid error, label this, that is, give this one the place value 0, 1, and then 2. So move to the next one. That will be 4 times n plus 4 times n plus 1 times n. So do the same thing to this, 0, 1, 2. Are you following? And then equal to, sorry for my use of word, but I just have to use it like that to save my time. So that will be what? 7 times n plus 1 times n plus 4 times n. And that will be 0, 1, 2. Is that taken now? So let's see. This will become 2n squared plus 6n plus 3 plus 4n squared plus 4n plus 1. You know, this will become 1 because n raised to the power of 0 is 1. So 3 times 1 is 3. This one will also become 1. 1 times 1 is 1. And that's equal, this is what? N squared. So that will be 7n squared plus 1 times n, that will be n. 4 times 1, that is 4. So let's collect the like terms now. All n squared will come together. All n should also come together. And all the constant there should come together. So without wasting much of our time, this is 2n, this is 4n. That will be 6n squared plus 6n plus 4n. That will be 10n. 3 plus 1, that will be 4, equal 7n squared plus n plus 4. So if this 4 should come to this side, it becomes negative. So 4 and 4 would cancel. Now 7n squared, and this is 6n squared. Let's take everything here to the other side. We therefore have that 7n squared, are you following now, plus n minus 6n squared minus 10n equal 0. So if that should be the case now, this should give us a n squared and what else? This is just n, and so this will give us a minus 9n equal 0. Are you following? So if that should be the case, you can do two things here. You can factorize out n. If you do so, by factorizing out n, you are going to have what? N minus n equal 0. And you are going to agree with me, if I have A, B equals 0, A can be 0 or B should be what? 0. So for that reason, you can say your n is equal to 0, or you say n minus 9 equal 0. So n equal to 0 or n equal to 9. It's not possible for the base to be 0. For that reason, this one is cancelled. Are you getting it now? Therefore, our result is going to be what? N. Is that taken now? Alright, so please just say thank you to my daughter. Yeah, thank you. Alright guys, so result is what? 9. So that's how to tackle such questions.